In this next video, we're going to talk about frequency graphs. We're going to talk about the types of graphs, their characteristics, what they have to do with scales of measurement, and the required elements of graphs. So just to review, frequency distributions can be either a table or a graph, but they both have the same two elements. They both have a set of categories, and they both have frequencies. So let's take a look at how graphs are set up. First of all, graphs can use any scale of measurement, and they are organized with two axes. We have an x-axis, the horizontal axis, and the y-axis, the vertical axis. We place the categories on the x-axis, and the frequency is on the y-axis. The first graph we'll talk about is a histogram. And a histogram uses an interval or ratio scale of measurement. And the height of y on a histogram is the frequency, and the width of x corresponds to what we call the category real limits. If you will recall from lesson 1, when we have interval or ratio data, we use something called real limits because there are no gaps in between any points. Each of the points on the interval or ratio scale can be broken up into fractional parts. So we have to use real limits. So there's a bar for each interval that has to include the real limits for each interval. There's no gaps in between the intervals. Let's see what this looks like. So here's a histogram, and the frequency is on the left-hand side, and the scores are along the x-axis. And as you will notice, the bars touch each other. That is because we are acknowledging the real limits of the scores. So for the score of 1, the real limits are 0.5 to 1.5. For a score of 2, the real limits are 1.5 to 2.5, etc. So we have to make sure that all of the bars touch. So as we look at number 3, for example, a score of 3 would be here, but this is 2.5 and this is 3.5. This is a histogram. We're using interval or ratio data. You'll notice also that the table right here is exactly what is represented on this frequency graph. So the next type of graph we're going to talk about is a polygon. Again, we're going to use interval or ratio scales of measurement. The height of y corresponds to the frequency, as with all of them, and the width of x corresponds again to the category real limits. Instead of a bar, though, we're going to have a dot at each interval, and that dot is going to be centered above each score in a vertical position. It's going to correspond with the frequency for this category, and we're going to connect the dots to form a pattern, and we're going to extend the line to the junction. That's a lot of information, but let's take a look and see what a polygon looks like. So this is an example of a polygon, and again, so a score of 3, we have a dot that's represented there. These numbers are connected because we are acknowledging the real limits of the number. So a score of 3 goes between 2.5 and 3.5, for example. And as far as drawing the lines down to the juncture, when we have a polygon, we extend the lines to the corners of each of the graphs. I do want to have you notice one more thing. The scores only went up to 6, and our graph shows 7 different scores. Why is that? Well, that is because the real limit of 6 is 5.5 to 6.5, so we need to make sure that 6.5 is included in this graph, so we just extend it out to 7. And we do the same for the y-axis as well. The highest frequency is 4, but we're going to have 5 be our top number, and this is a polygon. A bar chart is another type of graph, frequency graph, but a bar chart is for nominal and ordinal scales of measurement only. So histograms and polygons, interval and ratio, but bar chart is for nominal and ordinal. Nominal, you don't have to order them at all in the bar chart, but ordinal is going to be listed from highest to lowest on the bar chart. The height of y, as always, is going to represent the frequency, and x this time corresponds to the category labels. They're going to be words, not numbers. There's going to be gaps between the bars, and that shows that the different categories are unique, they're separate, and they are categorical, There you go. So this is an example of a bar graph. This is showing different personality types, extrovert, introvert, and neurotic. And as you can see, the table over here shows the frequency, and then it's represented here in the bar graph as well. Which do you prefer looking at? Do you like a bar graph? Do you like a table? What helps you understand the data the most? It's an interesting question. All right. And actually, we don't extend this bar graph beyond 20 because we're not dealing with real limits with these. These are discrete categorical categories. So this is a bar graph. Once again, the bars do not touch. Okay, let's do a learning check. Use the graph to answer the following questions. How many scores are there in this histogram? And what is the sum of the scores? Pause the computer, write down your answer, and then come back. And here are the answers. The total number of scores is 15. How did I know that? Well, you just count up the frequencies. I count up 4 plus 3 plus 3 plus 2 plus 2 plus 1, and that gives me 15. That's how many people are represented in this graph. Now for the sum of the scores, how did we get that? Well, basically, you're going to count each score for its value. So I have a score of 1 here, and there's 4 of them, so that's 4 altogether. I have a score of 2, and there's 3 of them, so that makes 6. 1 plus 6. And then I have 3 scores of 3, which is 9. So 1 plus 6 plus 9, etc., until you get to 43. All right, here's another one. How many scores are there in this histogram? And what is the sum of the scores? Pause the computer and then come back. And here are the answers. The number of scores is 15. I'll do a quick check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes, 15 scores. The sum of scores is 62, and I would get that by adding 1 score of 1 plus 2 times 2 is 4, 1 plus 4 plus 3 times 2 is 6, and so on. So that's how you add up the scores all together. Okay, I'm going to talk about one more kind of graph. This is called the stem and a leaf graph, and I cannot wrap my head around this graph. Maybe you will like it better than I do. Some people love these graphs. It's another way of organizing the data, and it combines a table and a graph together. Each score is separated into what's called a stem and a leaf, and the stems are listed in columns with the leaf for each score written beside the stem. Okay, this will make more sense when you look at it. So this is a stem and leaf for these data right over here. So how this works is we take the number that's in the tens column. And so the lowest number I have here is 32. And the highest number that I have here is, help me find it, should be here somewhere, 97. So I know I'm going to have from the 30s to the 90s. So I'm going to make 3, 4, 5, 6, 7, 8, 9. That's the number in the tens column. And then what I'm going to do is I'm going to put a leaf, these are stems, I'm going to put a leaf for each number in the ones column that goes with the number in the tens column. So this will make more sense as we find these numbers. We have a 32 here, so 3 and 2 makes 32. And then we also have a 33, so 3 and 3 makes 33. I know it's just very strange. But what's nice about this table is I can look at this right now, and I know that most of these scores are in the 70s because this is the longest line of scores. 71, 76, 74, 73, etc. And I also know that there's sort of this looks like almost a bell curve here, that most of the scores cluster here, and then there's some on the extreme ends. So anyway, there you go, stem and leaf graph. Maybe you like it, I don't know. In the next video, we're going to be talking about the shapes of distributions, so I'll see you there.